Today we will study about simple crystallization process. This is one of the most common methods to separate the organic solids, and we need to know like when simple crystallization is preferred. So when do we prefer this? When there is a difference in solubilities of the components. Like impurity solubility and the organic compound solubility must be different. They must have the difference in solubilities in a suitable solvent. Like if I take the mixture which is having organic compound and impurities, let me take a mixture. So this is having an organic compound which I want, like which we want to separate, and there are certain impurities, the unwanted substances. Then one must be the criteria to consider simple crystallization technique. The organic compound solubility must be different, impurity solubility must be different, or else impurities must be insoluble and only organic compound must be soluble. Organic compound must crystallize and impurities should not crystallize. Okay, so when you dissolve this mixture in a suitable solvent, the organic compound must crystallize and impurities must be left behind. So this is the criteria. Okay, so there are certain things like which kind of solvent we have to select. There are certain conditions for the selection of solvent. We'll discuss it now. Before doing the crystallization process, we have to dissolve the organic compound and impurities in the same solvent. So what are the conditions for selection of a solvent? First thing, the solvent must not be inflammable. What does it mean? It should not catch the fire. And second thing, it must be chemically unreactive. It should not undergo any chemical reaction with the impurities or with the organic compound. And third condition, it should dissolve the solute more at higher temperature than at room temperature. More amount of solute must be dissolved at higher temperature than at room temperature. This is one more condition. That means on increasing the temperature, the solubility of solute in that specific solvent must increase. And how must be the impurities? Impurities must be insoluble, and if they are soluble, they must remain in the same solvent but they should not crystallize. When we talk of impurities, they must be insoluble in the solvent, or if it is soluble, there must be difference in solubilities. The solubility of impurity must be in such a way that it remains in the solution. It remains in mother liquor but should not crystallize. Okay, so these are the conditions for selection of a solvent. Now we will see certain examples of solvent which are suitable for crystallization process. We can select water as an example, alcohol, ether, benzene, acetone, chloroform, and carbon tetrachloride. So these are some of the examples of the solvent which are suitable for crystallization process. Now let us study examples of crystallization process. Example 1, I am just selecting a mixture of sugar and salt. So this is a mixture that I am considering. Now which is an organic compound in this mixture? Sugar is an organic compound and salt is inorganic compound. This is not an organic compound. So how do we separate these two substances from one another? With the help of simple crystallization. So what is a suitable solvent in this case? We take hot ethyl alcohol. We just take hot ethanol which will be serving as a solvent for this mixture. So when we dissolve in this hot ethanol, what happens? The organic compound sugar, it dissolves in the solvent and it crystallizes out. When you take the salt, it do not dissolve. So one is dissolving, the other is not dissolving, so it will be easy for us to separate these two substances. Now similarly, if I consider another example, let me take benzoic acid and naphthalene. So if I want to separate these two substances, what will be the suitable solvent here? Hot water. Water will serve as a solvent here, wherein benzoic acid will dissolve and naphthalene will not dissolve. So these are some examples. Now we'll see the whole procedure, like what are the steps that we do in crystallization process. Crystallization involves lot many steps. Like first we have to prepare the saturated solution, and then we have to do filtration, and then we have to crystallize the organic compound, then drying of it, and then if there are any colored impurities we have to remove them. So there are certain stages in the crystallization process. Now we will see them one by one. There are 5 steps basically in crystallization process. The first and foremost step is preparation of the saturated solution. So what we have to do here, we have to take a beaker and we have to fill it with some suitable solvent. Same solvent is not suitable for all kind of mixtures, so we have to select a particular solvent which is suitable for that particular mixture. Okay, and then we have to dissolve what? We have to dissolve the mixture which is containing organic compound and impurities, and we have to heat the solution. What we have to do here, we have to heat the solution. So when you heat the solution, what happens? As I told you, the solvent must dissolve the solute more at higher temperature than compared to room temperature. So whenever we heat the solution here, the organic compound solubility increases. Solubility of the organic compound increases. When solubility increases, what happens? Finally the solution becomes saturated. And how do you check the saturation here? You just have to dip a glass rod into this. So once you dip a glass rod and you just take it out, this is the glass rod. If you want to confirm whether saturation levels are met or not, you have to dip a glass rod into this solution. You just have to take it out, and once you take it out, on the surface of the glass rod, if you see any accumulation like this, if you see any scars formation, okay, it means that the solution is saturated and it is ready for the second step. So this is how we prepare the saturated solution. I hope you are clear with this. I'm just repeating the point once again. We have to take the mixture containing organic compound and impurities, and we have to dissolve them in a suitable solvent. And then we have to start increasing the temperature, which is possible by heating the solution. So once you heat, the solubility increases and the solution gets saturated. And how do we check the saturation here? We have to take a glass rod, dip into the solution, just take it out, and if you see any white scar formation on the glass rod, that's the hint for us that saturation levels are met. And now we are ready for going the second step. Now second step is filtration of solution. So what we do is we just filter the solution that we have prepared in step 1. So this is the diagram for filtration process. What we are going to do in this is we have to take a collecting beaker, so which collects the filtrate, and we will be taking a funnel. We just cover it with some filter paper or some suitable separator. So the solution which is prepared in step 1 will be poured into this funnel. So this funnel will allow the filtrate particles, that is liquid particles, but it will stop the undissolved impurities. The undissolved impurities will stay back on the filtrate itself, and the dissolved form of the organic compound along with the solvent, that is the solution, will pass through this beaker and it will be collected into what? Into the collecting beaker. So this solution which is collected, which is free from the undissolved impurities, we call it as a filtrate. So from step 1, solution is taken and it is considered for filtration process, wherein the undissolved impurities will be left behind on the filter paper, and the remaining solution will be penetrating through that and it will be collected separately in a collecting beaker. So in step 2, what we are going to get is we are going to get a filtrate. There is a chance that filtrate will be having some dissolved impurities as well. We'll just separate it in third step. Second step, we just remove the undissolved particles. If there are any dissolved impurities, we separate them in the third step, that is crystallization process. In crystallization process, we consider the logic that the difference in solubilities of the compound and the impurities. The component which is having less solubility, that will crystallize first. Component with the less solubility in the solvent, that crystallizes out first. So we just assume that the organic solid is having less solubility, and so it is crystallizing out first, and impurities are having more solubilities, so they are just remaining in the mother liquor. Okay. And what we are going to do in this crystallization process, we have prepared filtrate in step 2, right? The same filtrate is considered for step 3, and this filtrate is allowed to cool. So it should not be disturbed, it should not be shaken. So without any disturbance, it just has to be left free, and we just have to slowly cool it. So once you cool, what happens? The organic compound crystallizes out. So this is the solution. The organic compound in it crystallizes out. So these are the crystals. Crystals of organic compound. What about the impurities? The impurities stay back in the solution itself. Okay. So this is called mother liquor. So what happens to the impurities? Impurities stay here itself. Okay. So what are we going to do in crystallization process? I'm just going to repeat it once again. So here the technique, the logic that we consider is the difference in solubilities. The component which is having less solubility, that will crystallize out first. And as we consider the crystallization of organic solids, we just make an assumption that they are having the less solubility, and so they crystallize out first. What if the impurities are having less solubility? So impurities will be crystallized out first, and we continue the crystallization process further. Till we get the crystals of organic solid, we just continue the process. If impurities are having less solubility, they come out first. We just separate them by filtration process again, and then we continue the crystallization. So if we consider component that is having less solubility is organic compound, the crystals of the compound will be obtained in this process, and impurities stay behind in the mother liquor. Now how do we separate these crystals? Again we have to do the filtration process. So step 4 is again filtration of crystals. This is to be considered in step 4. So crystals will be separated. Crystals are separated, and the solution will be left behind. Now these crystals, maybe they are having certain, the colored impurities, or we just need to dry them. If they are having any wet content of the solvent, we just have to dry them, and if any colored impurities are there, we have to remove them as well. In drying of crystals, what we do is we just take the crystals and we pass the steam over them. Steam or hot air. So then what happens? The solvent particles will be taken away and the crystals become dry. So when we pass the steam or hot air, what happens to the crystals? They become dry. Like there is a chance that, ma'am, what if the water connects with the crystals? So to remove the water, what we do is we use the dehydrating agents. So these dry crystals, they are again subjected to concentrated sulfuric acid, or we take anhydrous form of calcium chloride. So these are the dehydrating substances. So they remove the water from the crystals. Now what happens? The crystals becomes completely dry. What is the nature of these two substances? They remove the water. So they are called dehydrating agents. We use a desiccator, and in a desiccator we keep these dehydrating agents, and we just keep the crystals in that environment. So then this H2SO4 and CaCl2, they remove the water content and they make the crystals almost dry, completely dry. And in sixth step, what we are going to do, we are going to remove the colored impurities. There is a possibility that even after the 5 steps, there is a chance that the crystals are colored. And what could be the reason for this color? The reason could be because of the impurities. So how do we remove this colored impurities? We have to redissolve the crystals in the solvent. Redissolve in the solvent, first step. And when you are redissolving, you just have to make sure that we will be adding charcoal here. Add charcoal, okay? And then we have to heat the mixture for 15 to 20 minutes. So during this process, what happens, as you know, charcoal is a very good adsorbent. It absorbs all the colored impurities. Let me take this as a beaker, solvent. So these are the crystals. I'm just assuming the color of the crystal as white, and it is having some colored impurities. Let it be green color, okay? Now when we use the charcoal, what happens is the charcoal absorbs all these colors. What is the purpose of this? It absorbs colored particles, okay? And what do we have later on? We just have the pure crystal. All the colored impurities will be eliminated from the crystal. We have to redissolve in the same solvent. We just have to add the charcoal, which is a very good adsorbent. It absorbs all the colored particles. What do you mean by absorbing? Accumulation only on the surface, okay? And we have to heat the mixture for 15 to 20 minutes. What is the necessity for heating? When we heat, what happens? The clogged pores of the charcoal, they become free, and the adsorption process increases, okay? The chance of collecting the colored particles on its surface increases. So once heating is done, so again we have to repeat the process, the crystallization. We have removed the colored impurities, yet the crystal is again in the solvent. So what we have to do now, we have to repeat the procedure. We have to repeat crystallization process again. Crystallization and then drying process. Crystallization followed by drying. If there are no colored impurities, 5 will be the last stage. If there are colored impurities, then step 6 will be the last stage. So I hope you are clear with this technique. Simple crystallization where heating will be there and also cooling will be there. When we do heating, it becomes saturated, and when we do cooling, the less soluble component start crystallizing out, okay? And if there are any doubt, please mention in the comment section.